In this video, we'll look at examples of how to solve for the linear equation when you're given 2 points. Here we have 10 problems, and each of these problems we're given 2 points. And I'm going to go over the first 5 problems with you. Then I'll give you the solutions to all 10 of these problems so you can work on them on your own time. Now, before we get into solving linear equations, it's important to remember that the points are defined as x comma y, meaning that the first value that you're given in the point is your x location, the horizontal location, and the second value is the y location, the vertical location. And then you could define where on this graph your point is. With 2 points, we can define a line. With 2 points, we can define the slope m and the y-intercept b. Remember, the slope is represented as rise over run, or delta y over delta x, and b is our y-intercept, basically where the line intercepts the vertical axes. So we can define that where we basically give another point at x equals 0. Our points are often referred to with subscripts. So when there's a value for x, we can call that x subscript 1. When there's a value for y, y subscript 1. And for point 2, we'll use x2 and y2. Now, we could define each point and solve each individual problem starting with that linear equation and the generic definitions of our slope and y-intercept. But because I know I can be asked to solve for the linear equation for an infinite amount of 2 points, then I can write out an equation using x1 and y1, x2 and y2 to define my slopes. So remember, the slope is defined as delta y over delta x. So I can either write that as y2 minus y1 over x2 minus x1, or I can write it as y1 minus y2 x over x1 minus x2. We can see that the signs are the only difference here, and they will cancel out because you're dividing them. So it doesn't matter which one you choose, whether you want the point 2 subtracted by 0.1 or 0.1 subtracted by 0.2. You just have to be consistent. If you're not consistent for the y and the x components of which one you're subtracting, you'll have a sign error. So as long as you do that, you're fine. All right, so you can solve for the slope relatively easily following this formula. Now, when we try to solve for the y-intercept, one way to think about that is to treat the y-intercept as a third point. Well, we know that the x value of the y-intercept would be x equals 0, right? That's a definition. It's where the y-axis crosses the x-axis. And when the point crosses this y-axis, the y value is b, and that's what we're trying to solve for. So I can write the slope, now that I've defined it, I will have defined it. The slope is equal to y2 minus the y value of the y-intercept, which is just b, divided by x2 minus the x value of the y-intercept, which is 0. Or I can write it as y1 minus b over x1 minus 0. Now the important thing is it doesn't matter which one you use. If you solve for your slope correctly, and the value that you solve for b in either case will be exactly the same, whether you use 0.1 or 0.2. Now we can rewrite this equation solving for b as y2 minus the slope times x2, or y1 minus the slope times x1. So knowing these two equations right here, I can solve for the slope and the y-intercept. And so we're going to do that for the first 5 problems, and that's how you solve for the linear equation for 2 points. Okay, let's take a look at the first problem. We have points -6, 0 and 2, 4. So I can plot that on my graph here. I got -6, 0 and 2, 4. So this is my x1, this is my y1, this is my x2, and this is my y2. So I can plug into this equation here to solve for my slope. I have y2 as 4, and I have y1 as 0. I have x2 as 2, and x1 as -6, and that's what we're representing here. So 4 minus 0 is 4, 2 minus negative 6 is 2 plus 6 is 8. So it gives me 1/2 for the slope. All right? So a lot of times you want to check your sign. This should be a increasing slope, and that's consistent with my graph. And so I'm at least confident in the sign here. Then I can solve for the y-intercept. I'm going to use this equation first. So y2, that's 4, minus m, the slope, which I just solved for, is 1/2, times x2, that's 2. So 4 minus 1/2 times 2, 1/2 times 2 is 1, so 4 minus 1, that's 3. So that's using 0.2 and the slope. I can do the same thing using 0.1. So 0.1, y1 is 0, the slope is 1/2, and x1 is negative 6. So 0 minus 1/2 minus 6, 1/2 times negative 6 is negative 3. Subtracting that from 0, that's going to give us 3 as well. So either way gives us the same answer. So that gives me more confidence I solved this one correctly. So I'll plug in what I solved for m and y-intercept into our y equals mx plus b equation. I got y equals the slope, 1/2 x plus the y-intercept 3. And I can draw a line between the 2 points, but realistically we draw a line all the way across it because the linear equation goes to infinity to the right side and to the left side. So that's why we draw these arrows on either side here. Okay, so we're going to do the same process for these points, 2, 6, and negative 3, 6. Okay, so same thing for the slope. We say y2 minus y1, 6 minus 6, x2 minus x1, negative 3 minus 2. So we get 0 over negative 5. That's a slope of 0. Well, that's consistent. We expect to see a horizontal line. A slope of 0 is a horizontal line. Then we get our y-intercept. Well, even without doing this equation, solving this equation, you might know what the y-intercept already is, right? So since it's a horizontal line, it's going to cross at 6. But let's see if this equation is still consistent. y2 is 6 minus the slope 0 times x2, negative 3. So that's going to give me 6 minus 0. Same thing for 0.1. If I use 0.1, I get y1, which is 6, minus the slope, which is 0, times x1, which is 2. Then I can plug in my slope and my y-intercept into my linear equation. Y equals the slope 0 times x plus the y-intercept 6, and this equals 6. I draw my graph. There's my horizontal line, and remember we extend the line all the way across. For problem 3, we have negative 7, 3 and negative 7, 1. We can look visually and we see that these points are going to produce a vertical line. So anytime you have 2 of the same x value, you're going to get a vertical line. From the previous problem you saw, anytime you get 2 of the same y values, you're going to get a horizontal line. Okay? So what's a vertical line going to give us in terms of slope? Well, let's take a look. We get y2 minus y1 over x2 minus x1. y2, 1 minus y1, 3. That's going to give us negative 2. x2 minus x1, negative 7 minus negative 7. That's just going to cancel itself out. That's going to give us 0. So anything over 0, it's going to give us infinity. If I have infinity for my slope, I can't use my traditional y equals mx plus b equation, right? So how do I write the mathematical equation to represent something with a slope of infinity? Well, on the horizontal line, we represented the horizontal line with y equals some constant. For a vertical line, we just represent it as x equals whatever that value is, right? So y is not part of this equation, so it doesn't play a role in determining what point is represented here. X is just negative 7 for any y value. So for problem 4, we have negative 4, negative 9, and 1, 3.5. All right? So we'll repeat the same process. Feel free to pause the video if you feel like you're getting the hang of it and want to solve this one on your own? Well, we have y2 minus y1 over x2 minus x1 again for the slope. 3.5 minus -9, that's going to give me 12.5 for my numerator. And x2 minus x1, 1 minus -4, that's going to be 5. 12.5 divided by 5 is going to be 2.5 for my slope. Right? So you can see that the slope doesn't always have to come to a round number. The slope can be any value depending on what the points are given as. I'm going to solve for the y-intercept in the same way. y2 minus mx2. So y2, remember, is 3.5 minus 2.5, the slope, times x2, which is 1. So 3.5 minus 2.5 times 1, that's 3.5 minus 2.5. That gives me a y-intercept of 1. We can do it to check using 0.1 and the slope. So it's -9 minus 2.5 times x1, which is -4. So that gives me -9 plus, because this negative signs cancel, 4 times 2.5, which is 10. So 10 minus 9 gives me 1 as well. So it checks out. So I have my slope here, 2.5, and my y-intercept of 1. So y equals the slope x plus 1. And if I graph it, we can see that the line does cross at y equals 1. And for the last problem that we're going to solve together, we have 0.24 and -2, -8. And we're going to go through the same process again. We're going to find the slope using delta y, -8 minus 4, and delta x, -2 minus 2. So in the numerator, we get -12. In the denominator, we get -4, which gives us 3 for the slope. We'll plug in 3 back into my y-intercept equation. I get -8 minus 3 times -2. So -8 plus 6, I get -2 for my y-intercept. We can repeat the process for 0.1 and the slope. We get 4 minus the slope of 3 times x1, which is 2. So we get 4 minus 6, which is -2. So I plug in our final solution for this linear equation is 3x minus 2. And so we can draw the line on the graph. We see that the y-intercept does cross, the line does cross the y-axis at -2, matching what our y-intercept will solve that. And we see that our slope is positive, which is consistent with the slope of +3. All right, I hope those first 5 example problems make sense to you. Try to solve the next 5 problems on your own. Here are the solutions. Try solving it without looking at the final solution. And you may even want to graph just to see if you visually can observe that the slope makes sense, at least from a sign perspective, and that the y-intercept is what you observe as well.